In this example, we are going to be utilizing the Pythagorean theorem. Now, keep in mind we've already been using the Pythagorean theorem in earlier sections, except we didn't necessarily call it the Pythagorean theorem. We just said that we were using it to find the distance between 2 points. And of course, that equation was c is equal to the square root of a squared plus b squared. And of course, then in this section, we are introduced to the Pythagorean theorem as a squared plus b squared, that's equal to c squared. And using just basic algebra, if I was to solve for c, then I would take the square root of this side of the equal sign, and I would have to take the square root of this side of the equal sign. And of course, this radical will cancel, and of course, this square will cancel, leaving us with c is equal to a squared plus b squared. But in this section, we now give it its formal name, which is the Pythagorean theorem. And typically, we use the Pythagorean theorem as it applies to right triangles. So I'm just going to pen in a right triangle here. And c is always going to be the hypotenuse in our a squared plus b squared is equal to c squared. And the hypotenuse is the length that is opposite the 90-degree angle. The other two are known as legs. You can mark either one A and B. It doesn't matter which one, but we just know that those are the legs. Now, in earlier sections, if we had a point here and we had a point here and we wanted to know the distance or the length between those 2 points, we would find the absolute value of the difference in the x-coordinates. That winds up being our A. Then we would find the absolute value of the difference in the y-coordinates. That would be our B. And then we would go ahead and use this distance equation here. But it's all the Pythagorean theorem, just the same. So for this problem here, for letter A, it says leg A is equal to 3 and leg B is equal to 4. So I'm just going to mark this as 3. And this is 4. So for the Pythagorean theorem, we don't have coordinates. We already have the lengths. And we're just going to use the lengths to help us find what's missing. And for this example, it's going to be the hypotenuse here, which is c. So we want to find this length here. And you can use a squared plus b squared is equal to c squared and go ahead and solve, or we could just go ahead and use this portion of it. So we'll do that. So c is equal to the square root of a squared, that's 3 squared, plus b squared, and that's 4 squared. That's equal to the square root of 9 plus 16. That's the square root of 25. And the square root of 25 is 5. So the length of the hypotenuse here is 5. And a squared is 9, b squared is 16, and c squared is 25, and of course 9 and 16 is 25. So we'll do the same for the next one. We have 6 squared plus 8 squared. It's 36 plus 64. That's the square root of 100. And the square root of 100 is 10. So if I have a right triangle with one leg of 6, another leg of 8, it has to have a hypotenuse of 10. And we'll continue with the other one. We have c is equal to the square root of 9 squared plus 12 squared. That's the square root of 81 plus 144. That's the square root of 225 is 15. And don't forget to use your calculator. You can certainly use your calculator, obviously, as these square roots come into play. And finally, we'll do the letter D here, the last one. We've got the square root of 27 squared plus 36 squared. That's equal to the square root. 27 squared is 729. Plus 1,296. That's equal to the square root of 2,025. And the square root of 2,025 is 45. Now, this is known as a Pythagorean triple. 3, 4, 5. A leg of 3, a leg of 4, a hypotenuse of 5. If you look at the next problem here, we have 6, 8, and 10. So we originally started with letter A as 3, 4, result was 5. B, we now have 6, 8, result is 10. So it seems as though if I took letter A here and multiply it by 2, I wind up with 6, 8, and then the result is 10. If I go ahead and I multiply letter A here by 3, I wind up with 9, 12, and a result of 15. So each one of these is a multiple of the other. And it seems as though whenever I affect the multiple of the two legs, it also affects the length of the hypotenuse. That's something to keep in mind as we progress through this section.